Hey everyone. So, hypothesis testing is a fundamental statistical method used to make decisions and draw conclusions from data. It helps us determine whether an observed effect is real or just due to chance. This process is widely used in business, science, medicine, and many other fields to support decision making with data rather than assumptions. At its core, hypothesis testing follows a structured approach. We start with a hypothesis, which is a claim or assumption about a population. There are two competing hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis assumes that there is no effect or no difference, while the alternative suggests that there is a significant effect or difference. Once we establish these hypotheses, we collect and analyze data to determine if there's enough evidence to reject the null. If the evidence is strong, we conclude that the alternative hypothesis is more likely to be true. However, if the evidence is weak, we fail to reject the null, meaning we don't have enough proof to support a different conclusion. One key aspect of hypothesis testing is understanding statistical significance versus practical significance. Statistical significance means the result is unlikely to have occurred by chance, based on a mathematical threshold. However, just because something is statistically significant doesn't mean it has real world importance. Practical significance considers whether the result is meaningful in its practical sense, such as whether a small increase in sales or a slight improvement in efficiency is actually valuable to a business. To make these decisions, we use alpha and beta risks. The alpha risk represents the probability of rejecting a true null hypothesis, also called a type 1 error. This means we conclude that an effect exists when it really doesn't. The beta risk is the probability of failing to reject a false null hypothesis, also called a type 2 error. This means we miss detecting a real effect that does exist. Balancing these risks is crucial when designing experiments and interpreting results. Before performing hypothesis tests, we often need to assess normality, checking whether the data follows a normal distribution. Many statistical tests assume normality, so if the data is not normally distributed, we may need to use alternative methods. Different types of hypothesis tests exist depending upon what we are analyzing. Some of the most common include testing means, used when comparing averages between two or more groups, such as checking if a new medication lowers blood pressure more than an existing one. Testing for variances determines if the variation in two data sets is significantly different, which is useful in quality control and process improvements. And testing medians, used when data is skewed or contains outliers, making it better suited than means comparison in certain situations. And finally, testing proportions compares percentages or proportions such as whether more customers prefer one product over another. Another key part of hypothesis testing is residual analysis, which helps check the accuracy of a model by analyzing the differences between observed and predicted values. Residuals show whether a model fits the data well or if there are patterns suggesting missing factors or incorrect assumptions. Understanding hypothesis testing is essential for making informed decisions in data analysis. It provides a structured way to evaluate claims, reduce uncertainty, and ensure that conclusions are based on evidence rather than assumptions. Whether in business, healthcare, or research, hypothesis testing plays a crucial role in uncovering meaningful insights and driving better outcomes.